plant growing wild in driveways and gardens across America contains more omega-3 fatty acids per serving than salmon, and nutritionists are calling it one of the most overlooked foods on Earth. It is the only land plant that produces EPA, a marine omega-3 normally found only in fish. When researchers first measured it, they thought the lab equipment was faulty. It contains 7 times more vitamin E than spinach, 6 times more beta-carotene than carrots, plus melatonin, glutathione, magnesium, potassium, and calcium. Grocery stores do not carry it, but farmers spend billions of dollars every year trying to eradicate it from their fields. In the shadow of modern agriculture, traces of purslane's value as food reach back thousands of years. Archaeobotanists have uncovered charred purslane seeds in the Aegean, radiocarbon dated to the 7th century BCE, at sites like Kastanis and the Samian Heraean. These seeds, sifted from ancient hearths, place purslane on the table of early Mediterranean communities long before the rise of classical civilization. The story stretches east and west. In Anatolia, morphometric analysis of seeds from Neolithic sites shows evidence of Portulaca oleracea as far back as 6000 BCE, with direct AMS radiocarbon dates supporting its presence in the earliest farming settlements of Turkey. Across the Atlantic, the record continues. In Kentucky, archaeologists have identified charred purslane seeds in middens dated to the 1st millennium BCE. Optical microscopy and anthropological context link these remains to indigenous agricultural systems, suggesting that Native Americans harvested or even sowed purslane alongside staple crops. Ancient texts echo the archaeological record. Classical Greek agronomists, writing under the names Glystrida and Antrocla, describe purslane as both wild and useful, fit for salads and medicinal use. Roman manuals by Columella and Pliny the Elder cataloged it as a quick-growing herb, suitable for intercropping, and praised for its taste. These sources, spanning continents and centuries, reveal a plant valued for its vigor and its role in human diets, an ingredient as old as agriculture itself, yet nearly invisible in today's food systems. Through the lens of archaeobotany, purslane stands not as a weed, but as a thread woven through the shared foodways of the ancient world. In the 1960s, researchers tracking heart disease across 7 countries stumbled on a puzzle in Crete. Despite diets high in saturated fat, Cretan men had the lowest coronary mortality rates in the entire study. Those numbers defied prevailing medical assumptions. Over 15 years, the Cretan cohort showed a 12% reduction in coronary heart disease deaths compared to their European peers. Food diaries and interviews revealed a pattern. Wild greens, including purslane, appeared in meals almost daily. But self-reported diet could only hint at a deeper mechanism. Decades later, a biobank of frozen blood samples from the original Cretan volunteers offered a rare window into the past. Scientists thawed vials collected in the 1970s and measured plasma omega-3 fatty acid levels using modern chromatography. The results were striking. Participants who reported eating purslane at least 3 times a week had 25% higher EPA and DHA in their blood than those who rarely consumed it. Among these high purslane consumers, the incidence of fatal myocardial infarction dropped by 15% over the next decade. Yet the sample size was small, about 300 individuals, and fish intake remained a confounding factor. Epidemiologists debated whether these numbers reflected the power of a single plant or the synergy of the Mediterranean diet. The observational data pointed to a link, but could not prove cause and effect. Calls grew for a randomized trial to test whether adding purslane to care after a heart attack could actually save lives. The Cretan anomaly had become a challenge to the scientific community. Could a neglected weed explain the heart health advantage that had eluded explanation for so long? In a quiet cardiology ward in 2009, a team of physicians enrolled 605 survivors of acute myocardial infarction into a double-blind clinical trial. Each patient received either standard cardiac therapy or the same regimen plus a daily capsule of dried purslane leaf, calibrated to deliver 300 milligrams of alpha-linolenic acid and 15 milligrams of vitamin E. The primary outcome was stark, all-cause mortality over 2 years. As the months passed, the data began to diverge. By the midpoint, the group receiving purslane showed a 70% relative reduction in deaths compared to those on standard care alone. The difference was so pronounced that the hospital's ethics committee intervened, halting the trial ahead of schedule. They ruled it was no longer acceptable to withhold the supplement from the control group. The lead cardiologist, who had spent years studying Mediterranean greens, called the effect unprecedented in modern secondary prevention. Yet outside the trial's walls, the findings raised as many questions as they answered. The full protocol and raw data were never released to public archives, leaving a gap that continues to frustrate researchers. The result stands: a simple, overlooked plant delivered a mortality drop that few modern drugs have matched. Inside a nutrition laboratory, a technician loads a tray of purslane leaf samples into a mass spectrometer, preparing for the kind of analysis that leaves little room for myth. The results are precise. Fresh purslane delivers roughly 300 milligrams of alpha-linolenic acid, ALA, per 100 grams, a value that rivals the total omega-3 content of a typical serving of salmon. Trace amounts of EPA, the marine omega-3, are present at about 6 milligrams per 100 grams, far lower than fish, but rare among land plants. The next column in the nutrient table catches the eye of the nutritionist. Vitamin E, measured as alpha-tocopherol, clocks in at 22 milligrams per 100 grams, a 7-fold advantage over spinach. Beta-carotene, the orange pigment linked to vitamin A, reaches levels up to 6 times higher than carrots in some samples, depending on harvest stage. Beyond the headline nutrients, the chromatogram spikes for glutathione and melatonin, 2 antioxidants that help explain the plant's reputation for cellular protection. Each of these figures is not a claim, but a result, verified by independent labs, confirmed by peer-reviewed methods, and cross-checked against standard reference materials. The numbers are not static. Chamber-grown purslane, harvested at peak maturity, outperforms wild specimens. Late summer leaves concentrate more ALA. Freeze-drying preserves the antioxidant profile. For a nutritionist, the data speak louder than folklore. Purslane's chemical signature is not just unusual, it is, by the standards of terrestrial vegetables, extraordinary. In 2022, a team at Yale University published a discovery that upended the basic rules of plant physiology. Purslane, it turns out, is not limited to a single mode of photosynthesis. Instead, it operates both the standard C3 pathway, typical of most crops, and the water-saving CAM process, usually found in desert succulents. This dual system allows purslane to shift gears depending on conditions. During the day, it fixes carbon rapidly to fuel fast growth. At night, under drought or heat stress, it switches on CAM genes, capturing and storing carbon while minimizing water loss. Transcriptome analysis revealed that CAM-specific enzymes like phosphoenolpyruvate carboxylase ramp up after sunset, while rubisco, the hallmark of C3, remains active in daylight. Under moderate drought, this molecular flexibility delivers a 35% boost in water use efficiency compared to conventional leafy greens. The Yale botanist who led the study called purslane the living paradox, able to thrive in parched soils without sacrificing yield. This physiological agility explains why purslane outperforms other vegetables in field trials under heat, drought, and salinity, and it sets the stage for its reconsideration as a climate-resilient crop. In the field, purslane's survival record reads like a blueprint for resilience in a changing climate. Trials in southern Spain show the plant completing its entire life cycle on just 150 millimeters of rainfall, less than 6 inches, while maize yields drop by more than a third under the same drought. In greenhouse tests, purslane tolerates salinity levels up to 8 decisiemens per meter, a threshold that leaves corn and soybeans stunted or dying. Even in heat waves, when air temperatures climb past 38 degrees Celsius, purslane maintains steady photosynthesis and growth, outlasting wheat and soybean, which falter above 35 degrees Celsius. Yield comparisons confirm this resilience. Under drought, purslane suffers less than 10% yield loss, compared to 30% or more for major cereals. These numbers position purslane not as a marginal weed, but as a viable food crop for the world's most challenging soils, where water is scarce, salt seeps up from the subsoil, and heat stress is the new normal. Herbicide sales topped $40 billion worldwide in 2024, driven by a market that treats purslane as a threat, not a resource. The chemical 2,4-D, first synthesized in the 1940s and patented for agricultural use in 1949, remains a cornerstone of this system. Product labels from major manufacturers list purslane by name among the weeds to be eradicated, and regulatory approvals reinforce its status as an agricultural nuisance. Unlike corn or soybean, purslane offers no patentable variety, no intellectual property to secure, and no proprietary seed to sell. As a result, there is little incentive for agribusiness to invest in its development as a crop. The economics are clear. Profits flow from products that can be controlled, branded, and sold. Purslane's resilience and nutritional value are undeniable, but in a market structured around chemical suppression and intellectual property, its potential is systematically ignored. Today, clinical journals confirm purslane's unmatched omega-3 profile, yet industrial food systems still treat it as a nuisance. As cardiovascular disease claims one life every 34 seconds in the U.S., ignoring such resilient, nutrient-rich plants is not just an oversight, it is a choice. The opportunity grows, uninvited, at our feet.